Okay, our webinar today is on stubble, straws and carbon, panels, pellets and alternative uses. In this webinar, we will hear from three speakers. First up, we will hear from Graeme Anderson from Agriculture Victoria, who will speak on the benefits of putting stubbles into building products to capture carbon for the long term. We'll then hear from Steve Layfield from Ortech Industries, who will share how they are contributing to positive carbon farming by using straw stubbles in building products, which would otherwise be burnt after harvest, contributing to carbon emissions. And then Ray Davies from the Pyrenees Shire Council will discuss how local farmers are converting stubbles, straw to energy as one means of alleviating the need to burn stubbles in autumn. And Ray will also share a pilot project with the Skipton Hospital. So we've had a lot of interest in today's webinar with about 130 people registering, which is terrific. And we've got quite a number of you online live today. So first up, we've got Graeme Anderson from Agriculture Victoria, and most of you would know Graeme. Graeme is an experienced science communicator and extension leader with Victoria's agriculture sector, and he leads a small team who deliver climate risk services, which assist farmers and advisors in making sense of emerging issues and how to adapt their local farm systems. So over to you, Graeme. I'll pop up your slides.
Thank you. Thanks, Heather, and welcome presenters and welcome everyone out there. Thanks for joining us today. Really good chance to talk a little bit about stubble and straw and carbon and productive uses for it. So we've got a great bunch of talks and plenty of room for questions after the slides. So thanks, Heather. I'll go to the next slide. I guess just setting the context, one of the key things is that most farmers aim to retain their stubble, and there's been a fantastic amount of work done with conservation tillage and working right across the grains industry for maintaining profitable systems with retained stubble. And we know there's been a lot of research done on it. Stubble retention's got really well documented benefits for nutrient recycling, reducing erosion, keeping ground cover, improved rainfall, infiltration, and reduced moisture evaporation, and all sorts of good stuff. So across Australia and in most seasons, levels of stubble, growth and production and retention varies a bit, but also in some seasons, and we're coming off a pretty high yielding season last year, and especially in some of the high rainfall zones and median rainfall zones, some farmers can have the issue of having too much stubble. So what to do with it? And the question is, can we put it to more productive uses that drives a lot of economic development? So next slide, thanks, Heather. So I just wanted to context that, and for anyone that's looking for all of the great work that has already been done around stubble retention and all the good things it does, there's a great amount of work that's been done by GRDC and their partners. So head to that Stubble Initiative site, some really good resources there. Next slide, thanks, Heather. And there's lots of work that's sort of been done around the various phases of the season when it comes to, how do you manage stubble and stubble loads post-harvest, through the preparation phase, or dealing with seeding when we're dealing with larger stubbles, also the agronomy issues of disease and pest management, and also different approaches to how it's dealt with stubble in the harvest side of things. So all of that is really good work that's been done. And the next slide, thanks, Heather. And just pointing that if you're seeking some of that information, there's been some really good work done, again, partnership with GRDC and local farming systems groups. So if people are after some of that really good agronomy and management work on stubble management, please head to that website. There's each farming groups basically work to basically have a local stubble management guide, and there's lots of good stuff there. So just thought I'd do that first, and then we'll get into the next bit. Thank you. But in some years we do have too much stubble, and then the issue is, well, yes, we do occasionally see it being burned, but there's also lots of really productive things that are being done with stubble, not just here in Australia, but also overseas. And, you know, there are export markets for straw. There's markets for straw and bedding in lots of animal industries and litter. There's pelleting stuff, which is used for energy, or it's used for just making it better to handle for things like other industries such as, you know, kitty litter and all of that stuff. And there's lots of different building types of products that can be made from straw. So today is a great opportunity just to hear from a couple of people who are doing fantastic work, just trying to look at, well, how can we use some of this excess stubble and put it to good use? Next slide, thanks, Heather. But also just want to point out, there's obviously a lot of discussion at the moment around moving towards, you know, low carbon and zero carbon economies, and the potential opportunity that sits here with the, you know, more productive uses of straw. And I've just got a little example here, a bit of an image about the positive carbon story that comes with sustainable use of either forests or crop stubble. So if you imagine, we can start with it, you know, most people are familiar with the forestry example, where if you go out and plant a tree, that tree will grow and it'll take in carbon dioxide from the atmosphere and it'll put it into wood. And basically, you know, as we know, if you harvest some of that wood and the wood then gets used into building products, you've got some carbon that was in the atmosphere a few years earlier is now actually sitting there in a housing floor or in some furniture or something. So you've taken carbon out of the atmosphere and put it to work, as well as, you know, putting it to good use. So, but of course, also with some of those trees, when you do harvest, you might have residues and waste, and some of that can be converted for energy, and then that carbon's then released back to the atmosphere. But even if you just grew the tree and you know, just burned it for firewood, you're basically turning over carbon that you've taken in to begin with. So essentially with this biomass story, you have what's close to a carbon neutral sort of cycle. You're dealing with carbon that you've brought down to Earth out of the atmosphere, and then you're putting to other uses. And if it goes back in the atmosphere, then you're retaking it up with regrowing that forest again. So I want to move to the example of now, if you do that with straw, that we grow straw, it's part of our cropping systems. Largely that straw is retained. It does decompose over a year or two and ends up back into the atmosphere. So that's all good, and that's a sort of a carbon neutral cycle, replaces itself. But if you take some of that straw in some years and you put it down into the bottom right corner into building products, you've actually taken some carbon out of the atmosphere, you've taken that straw, put it into a building product, and then that carbon will sit in a house as locked up carbon for the life of that those buildings. So you've actually created a net positive flow of carbon out of the atmosphere and into building products. And also, even if some of that and you've got some waste and you do happen to burn that, such as for heat energy, yes, that carbon is released, but then just your straw in the crop next year will just take that back and use it again. The key bit here is that if you're using those straw pellets to provide heating or energy, and it's displacing a non-renewable fossil fuel, you've actually created quite an important carbon gain in that process. So while the turnover of straw might be carbon neutral, if you're using it for some energy production, you're actually displacing fossil fuel. And so there are different uses for heat energy, especially across rural Australia, where this could potentially play a role. So that's what we're going to hear about today, is some examples of people doing productive things with straw. And it's got a positive carbon story, but also got lots of other great benefits potentially if in the next 20 years we can see more of this happening across rural Australia, because, you know, straw is produced in a much wider area of the country than just forestry. Often a lot of forestry is in the higher rainfall zones, but as we know, straw can be grown wherever we've got our grains industry. It also potentially offers some income streams for some years with that excess straw, which is a good thing, but also offers a lot of employment opportunities. And in the end, for consumers, there's some pretty low carbon or positive carbon products potentially on the market. So today's really just flagging that, and I'll sort of finish there and we'll go to some people who are really doing some interesting stuff. So thanks, Heather.
Great. Thanks for that, Graeme. That was a good introduction and setting the scene for our next two speakers, and always a good reminder there about the carbon cycle. And I've popped that Stubble Initiative GRDC link into the chat box for everyone if you would like to click on that in your leisure. Okay, so we'll hand over next to Steve, and I'm just setting you up, Steve. So while we're getting Steve's slides up on the screen, Steve Layfield is from Ortech Industries, and he's a technical sales representative. And so today we're looking forward to hearing from Steve on their sustainable building materials using straw stubbles.
Yeah, thanks for that, Heather. Just before I whack up the slides, I'll just run through, and I brought some of the product in here as well, just to show what it is physically too, because we have a pretty neat sample here. But definitely I want to say first thanks to Graeme and Heather for thinking of us, and it's great to have a bit of an opportunity to talk about what we do. And we've just found over the past 2-3 years that our company and our building products are just growing by popularity as the industry is changing with building materials. We manufacture DuraPanel, and I took your sample in here, which you can actually see the cross grain, hopefully, depending on the lighting in here, but it's actually straw stubble that is bound with heat and pressure to form this panel core. It's wrapped in a recycled craft paper liner, and then we can add material finishes on the face of it as well. And we export that all over the world. I'll start off with the presentation here, so just bear with a sec. Is that all good there, Heather?
Yes, that's great. Thanks, Steve.
Perfect. So, history on DuraPanel. Some of you may be aware that this product has actually been around for a very long time. It actually originated from Sweden when it actually went to England before it came to Australia. It was brought over just after World War II, when there was a shortage of building materials in Australia in 1954. So we had, it was called Stromet board back then. They set up the manufacturing plant in Bendigo, Victoria, because that was the heart of the wheat belt. And basically, that panel system ended up in a lot of houses throughout the 60s and 70s, used by some very affluent architects as well, with their sort of skillion roof designs, flat roof designs, when they were all the rage back in the 70s and 80s. So it's funny how that sort of teetered off in the 80s, but now it's come full circle again, and those sort of house designs are becoming popular once more, and hence our product is getting back into the industry in the residential market. Over those years since 1954, it became Ortech Industries in 1980, where predominantly we focus on commercial applications, where DuraPanel's specified for projects such as Melbourne Convention Centre, airports across Australia, convention centres in New Zealand, all the way to manufacturing facilities in Italy, Greece, Poland, everywhere. So it's amazing where some of that stubble that is harvested in that wheat belt is just ended up everywhere across the globe. A bit about the farming and baling and purchasing. So obviously, being in the wheat belt, we sort of source a lot of our stubble from Elmore and those sort of regions around there, usually sourced within a 100-kilometre radius from our factory. The straw could be any sort of variety nowadays with our manufacturing. We've really honed in onto just any variety, but generally it's Scout in those regions that we use. And basically, the straw contractor will just come in and bale up those bales, and then we purchase that from the farmers. So it's a great to provide another secondary source of income for them, where we can turn that into a building panel. There's a few slides here of the manufacturing process, which is a really great thing. It's a very clean process. So basically the bales are loaded up onto our conveyor belt. They're teased and broken up into loose straw, and they've run across another conveyor belt, which we call a vibrator, and then down the hopper, and then in between two heated plates, where extreme heat and pressure is applied to form that panel core. So what actually happens is there's no glues or binders used in the manufacturing process. It's actually the lignin in the straw that is extracted, helping bind that core together. And the really good thing about this is it gives us great thermal mass, gives us a very good acoustic properties, and it gives us a very dense board. So in the building industry, while we do a lot of convention centres, airports, things like that, is that it is just naturally a very good acoustic panel. For some reason, it just handles low frequency noise right up to high frequency noise better than 3 layers of plasterboard. So that has been sort of the main driver of our business for a very long time. Talking further from what Graeme was saying, obviously the carbon impact is a big ticket item for a lot of people and architects and building designers nowadays. Everybody is trying to look at things and buildings, designing them with the end in mind. A great story that I've had for a long time is when we supplied our partition wall system for the Sydney Olympics, the Green Olympics. We had over 2 kilometres of DuraPanel manufactured for that. They set it up in the media centre there for the Olympics, and basically at the end of that, they put the panels through a malter and spread them over the gardens in Sydney, which really does show that true cradle to grave life cycle of our panel. We've calculated roughly 31 kilograms of carbon dioxide is extracted from the atmosphere, and 8.5 of that is stored as carbon within the panel. Another key fact that we say in that bottom picture there in the bottom left-hand corner was some of our housing. Ortech Industries also produce modular buildings using DuraPanel in the walls and ceilings. And we do a lot of work with Kids Undercover, Anglicare, a lot of affordable housing and social housing industries, where we have over 900 of these in the field. There's a great little note there where it sort of takes 7 acres of straw to build a standard 3-bedroom house that's renewable every year. When you compare that to half an acre of 44 trees, it takes that the same job, but it regrows every 30 years. So it's a really good sort of comparison there to our building products versus conventional. Some of the project applications we can see here, just as a bit of an example, these are just a few, but we've got Casey Field's AFLW Pavilion where they've just got our natural finish DuraPanel in the ceiling there. Melbourne Convention Centre, there's thousands of square metres of that product there, right to residential and 180 desalination plant too, where that was a very high acoustic criteria that we had to meet. So that was a really good project to have. The other things that we achieve with our product and what we get specified for is fire resistance as well. Being such a densely compressed straw product, it actually doesn't burn, it actually carbonizes. Similar like burning a phone book, you can hold a blowtorch to the face of the DuraPanel and just watch it carbonize on the surface, and basically it self-extinguishes, it doesn't get any heat transfer through the panel, and you can scrape away the carbon and still see that golden straw right behind it. So that is another really cool characteristic about it. Basically, that's sort of what we do in a bit of a nutshell at DuraPanel. I think that's pretty much it for me, Heather. We'll leave it to the questions after this.
Great, thanks, Steve. Yeah, very, very impressive projects there, and yeah, I did take away that 7 acres of straw to build a house, and that straw will regrow in a year. So that's yeah, pretty great statistics for that. So thanks for that, Steve. And yes, if you do have questions for Steve, yeah, pop those in the chat, and we'll get to those later in our webinar. So I will now hand over to Ray, and I'll just give Ray control so he can pop up his slides. So Ray is representing the Central Highlands Straw Alliance and has also been the Manager for Economic Development and Tourism at the Pyrenees Shire for the past 12 years. And much of Ray's role is focused on infrastructure that supports the sheep, beef cattle and grains and wine manufacturing sectors. And since 2017, Ray has been working with a group of 9 farmers who are considering bioenergy and potential markets for their stubble straw. So we will now hear of another great example of how local farmers are converting straw to energy. So we'll just get your slides up, Ray.
Thanks, Heather. I'm just looking for the right file here to see where I'm at with things. So it won't be a second. Can you see that, Heather?
Not yet.
Right, okay.
I can put them up at my end if you like. Oh no,
Here we
here
go,
they come.
Heather.
Here they come.
Yep. All right, I'll just put that into slideshow. Go back to the start. Firstly, thanks Heather and Graeme for the opportunity to talk to this today. Council was approached back in 2016 by a group of farmers nearby to Beaufort looking at alternatives for straw to the traditional autumn burning regime that's been in place, and that group consisted of 9 farmers at the time. We've had a couple more join more recently. The group crop about 14,000 hectares and produce about 50,000 tonnes of straw annually. And so we looked at a range of options, but of particular interest to the group was bioenergy, and I'll come to that in our presentation shortly. Obviously, burning is not the most acceptable practice in terms of it being a dirty and sometimes dangerous thing where controlled burns can become uncontrolled and require reaction by local fire brigades, many of which are volunteer farmers themselves. So the things the group were keen to look at initially was to establish a straw pellet manufacturing facility that might be a supplier for a bioenergy market yet to be established. And we initially had the support of Regional Development Victoria with some Food Source Victoria funding that enabled us to conduct a feasibility study and business case for that particular project. The slide I've got up at the moment is simply probably a pretty familiar one to most watching today. It represents, according to the farmers that provided this snap to me, around about 150 tonnes of biomass that are burned within a couple of hours on an afternoon. Just to put that into context, we're currently doing a pilot project where straw pellets will be used to substitute LPG that's currently the heating fuel for hydronic heating and hot water service at the Skipton Hospital. We estimate that the straw pellet replacement will be about 200 tonnes, so that cloud there represents about 9 months worth of energy based on those figures. One of the things we looked at was what are the options for large straw bales. We did some analysis on what the lowest cost would be to produce a straw bale and examined markets for that, including biomass, but also things like the potential for use in things like mushroom industry, straw for bedding in intensive animal and those sorts of opportunities. As well as another thing that we investigated was the development of straw pellets, and the original business case that we looked at was a standalone factory type facility, and during our investigations and examination of that, we became aware that Crone were developing this piece of equipment, the Crone Primos 5000, which is, as you can see, an in-paddock pellet manufacturing machine drawn by a tractor of somewhere between 350 to 500 horsepower. So this is a piece of equipment that's been trialled by our group locally in the last couple of seasons and was operational up until a couple of weeks ago, producing pellets that'll supply the Skipton Hospital in the not too distant future. The next slide here is simply a visual of what those pellets look like. They're about 16 mil in diameter and of variable length. So we started a relationship with Beaufort and Skipton Health Services back in about 2012, and the facility you can see on the current slide is actually a wood chip operation that was commissioned in April 2014. The fuel supply of those wood chips comes from a sawmill located only about 10 minutes drive from Beaufort. So the story being, how can we localise energy supplies and provide greater opportunities for people within the region, as opposed to energy supplies going off to multinational companies where the local community doesn't necessarily see a greater benefit out of local energy supply solutions. The facility you can see there has been operating satisfactorily for about 7 years, and the hospital recently told me that they've saved a significant amount of energy through the use of that facility in Beaufort. So we re-engaged with them again after we started work with the straw group and looked at a business case that examined energy supplies not only for their thermal demands for hydronic heating and hot water, but in this case the potential for an electricity supply, and two systems, one being a steam combined heat and power system and the other one gasification technology, were factored into that business case. And then thirdly, we had a heat only system, ideally using straw pellets for simplicity at the hospital, for transport and storage and logistical simplicity, rather than having the hospital having to handle large bales going into a system. So the hospital board selected the heat only system as the simplest way forward, and the project was subsequently funded by the Victorian government through its Renewable Communities program. And the slide there illustrates that it's ended the procurement phase. It's actually the construction phase now, and I'll show you a slide of that construction shortly. But ultimately, the straw group will be entering into a straw supply arrangement with the hospital service as part of this pilot project. So this is work in play at the moment, a photo of the site on the 12th of this month. There's currently a roof going over the containers this week. Boilers are inside those containers that are currently being worked on at present to be commissioned. And sort of in the foreground on the right-hand side of the shot there, you can see where the hopper is for receiving the pellets upon delivery, and a ladder leaning against the belt elevator system that will take the straw pellets into the storage container at the back of the boilers. We're expecting the facility to be commissioned somewhere towards the end of May at this stage of the game. So just quickly, a quick recap on what the benefits that we see. I won't read this word for word. I think, Heather, the slides from today will be made available to the participants, but just quickly on the benefits that we see are that we're creating a new renewable energy source that displaces fossil fuels, in this case LPG is being used to meet the thermal demands for hydronic heating and hot water at the hospital. It's a pilot project that can be replicated, particularly at other hospitals where they are located in wheat belt areas that may not be connected to natural gas, and in particular those that are reliant on LPG. There's the potential to develop a new industry out of this, because the technology that is being installed at Skipton is imported equipment from Europe. Czechoslovakia is a location where the boiler systems are manufactured at present, but this is a potential manufacturing opportunity for Australia once the technology becomes more familiar within this country. So the other large benefit is that the dollars spent on energy by the hospital remain within the local community. A local farmer will be providing that supply. They're using a local contractor to transport the materials to the hospital. So that's two businesses that will derive some sort of income locally as a result of the replacement of the LPG system. And finally, it comes back to the ability of farmers, once this type of technology is more broadly adapted, an alternative to burning, so that materials can be taken from the paddock and used as a fuel source for this type of project, and other potential opportunities that also are being invested by our group that would look like or comprise what we would call back of the meter type combined heat and power technology that could be a potential electricity source for manufacturers in rural and regional Victoria. So that's under further investigation by the group at present, as well as the opportunities for biogas systems where gases can be captured off straw combined with other green materials such as food waste and organic materials. So there's some of the things we're looking at the moment, in addition to delivering the pilot project at Skipton. And just finally is a quick slide. This one is of a containerised gasification system that would generate electricity, pre-packaged in a shipping container that could be a modular system easily delivered at a location where there was a requirement for energy. And that's where I'll leave things for the group to make some questions. Thanks, Heather.
Great, thanks for that, Ray. Another great example of sustainably using stubble straw for bioenergy. So thank you for sharing that and the benefits of converting straw to energy. So we now have some time for some discussion and questions. So if you do have a question for one of our three presenters, please start putting that into the chat box, and we'll get to those questions. And while we wait for those questions, Graeme, you have a couple of questions for both Steve and Ray to get us started.
Yeah, I do. There's a few, great presentations. Thanks, Ray and Steve, and congrats on the great work you're doing. And, to me, they're quite exciting about, these are earlier days, but the potential for both of these to really grow over the coming decades as we're looking for, local development, rural development and sustainable, local energy and production. So it's a good story. One you probably come across, Ray, some people get a bit concerned sometimes about burning stuff, but have you got any comment on how you reply to the sort of the emissions standards for burning, like of a controlled device compared to perhaps the smoke from a paddock? Any comments there? Is it?
Yeah, so the emissions from these systems are the technologies developed to European standards, which would easily meet Australian equivalents in this country. The amount of output falls below EPA triggers in the case of the Skipton pilot project. But what we'll see when Skipton's commissioned, I would expect, would be very similar to that at Beaufort, where the wood chip facility, you cannot see smoke from the chimney when it's operating. And if you think of it a little bit like a car that's running well, you won't see puffs of smoke coming out of the exhaust pipe. But if you do start seeing smoke, you've got a problem there somewhere that needs to be rectified. And that might be, you know, moisture in the fuel or something of that nature. But ideally, when the system's operating well and the wood chips at Beaufort are delivered at a certain moisture level within the supply arrangements, and when the politicians arrived to do the official launch of that facility a few years back now, they asked that very question, oh, where's the smoke come from? And when I sort of pointed to the chimney stack, they were quite amazed that there was nothing really visible in terms of puffs of black smoke coming out.
That's right. And I guess that's the point, isn't it? This is a highly technical, you know, high-tech device that's burning it, not the old incinerators from the 70s, you know. So now that's great work. So we've got some good questions coming in, and I've got some more questions too, Heather, but it's great. We've got Colin Peace, obviously online today. He knows a fair bit about straw too, so welcome, Colin. So there's a question there from Colin for Ray. How are the pallet costs looking these days?
Yeah, there's the business case was based on an assessment from memory at around about $110 per tonne. There's a little bit of fine tuning with the technology that's producing the pellets, and there's probably still a little bit of give and take in those numbers at this stage.
Yeah, thanks, Ray. Yeah, and I guess that machine you've had it operating. I mean, it's amazing to think that it's an in-paddock machine, and it does look to go pretty slow though. For farmers who like to go pretty quick through the paddock, this is not one of those machines, is it, Ray?
No, that's probably one of the drawbacks. Is you're looking at throughput of somewhere around 5 tonnes per hour, and with Graeme, I'm sure that they're you know, keeping a close eye on the further development of the machine to make sure that it's going to be operating satisfactorily for all concerned.
No, that's great. Thank you. So just one from Colin for you again, Ray, and then we've got a few questions for Steve. So get ready, Steve. But Ray, Colin's just saying it's a great year to promote these systems. The straw prices are low and appear to be so for the foreseeable future. Have you seen much interest in home heating with pellets as they do in New Zealand?
We haven't examined home heating with this group at this point in time. Our focus has been more on getting a hospital system up and running to a point where it can be replicated at other rural hospitals, and there's a fair bit of interest by those in the southwest nearby to Skipton as to what's going on with this pilot, and yeah, pretty close scrutiny, particularly for LPGs, their only energy source for thermal needs.
Yeah, fantastic, Ray. I mean, and congrats again, because you know you've been innovating out there and you work with the farmers, and the potential is for hundreds of these across rural Australia, but someone's got to start, and it's always more expensive and more challenging when someone's trying to prove it the first time. So well done. So Steve, a few questions for you popping up. One was just in the process of the straw. What sort of straw do you use? You know, is it wheat or is it barley, oats? Can you use anything? And then, is there particular lengths and baling sort of that you needed? I imagine it's not just any straw will do.
Oh, it's pretty versatile. Like I mentioned before, we've fine-tuned our machinery now, like the shear blades, which actually cut the straw between as they jam it between the two headed plates. We're actually able to use quite a large variety of straw. So We do mainly use wheat straw. However, we can also switch to rice straw as well. In fact, when we've transferred our technology over to other countries, including Indonesia, predominantly was using rice straw, which can be a bit more abrasive during the manufacturing process, but we're definitely on top of that. In regards to specifications, basically the straw's got to be mature, cut and windrowed prior to the baling, and we generally, it's interesting. Originally, it was 230 mil to 400 mil of stubble that we were after, but we're actually finding that we can use shorter stubble now too. So again, our machinery has sort of become that far along that we're able to use a lot of varieties and lengths. Basically, we just want a high and fibrous strength is really what we need for a good, strong panel core.
Yep. And then baling, you don't want anything that's really super compressed already. So
yeah, it shouldn't be too. We generally pick up the 8x4x4 bales. We don't. High density baling can be issues, and same with like looser straw can cause us issues as well. But yeah, just somewhere in the middle is pretty good, and we try and get a moisture content of around I think it's 14%. Is what we're after as well. So when straw bales are stacked or field dried, we usually take the top bales off and take the straw underneath that.
yeah, okay. And just from a straw and storage point of view, like, are you after stuff that's fresh out of the paddock, or can straw be stored for a while?
Yeah. It can be stored. We do have barns at our factory as well, where we purchase in and keep that stock and let it dry out in the barn a bit better. Obviously, yeah, if it's damp straw, it can cause wet spots in the manufacturing process. So we always check that before we put it onto the machine for that moisture content. But yeah, generally storage under cover where we can, including on site. Otherwise, if it is field dried, then we would take the top bales off. And dry those out in our barn, and then take the rest of the straw from there.
Very good, thank you. A few questions rolling in. We've got one about how many tons of straw are needed for that 3-bedroom house? So there's a good one.
Well, basically, it's 1 ton of straw yields about 50 square metres of panel.
Okay, yep.
So I'm not too sure on the calculations with what did we say before? Let's check it.
That's one you can work on in the background there, Steve.
Yeah, I can. But all I could say at this point is it's about 7 acres of stubble.
Yeah, that's cool. No, that's great. A question from Colin. Steve, can the Durra panel gain any preferred installation in any sort of government social housing projects, which also incorporate increased energy efficiency? Any comments on that?
Yeah, definitely. Like I mentioned before, we've already got a long track record with social housing companies like Kids Under Cover, which we've had for 30 odd years, and also Anglicare as well. So I'll definitely have a look into that. But it is a really good material for that because it provides that thermal mass. Also being locally manufactured, it's a good thing. But the other thing which is the panel has for it with these environments is that it's low maintenance, so it's very high impact resistant. And unfortunately, in those circumstances, that's a product that is required. So their alternative to social housing is actually having timber studs, and the studs would be at 450 centres, and then they'd actually have to line them with chipboard and particle board before they then plaster it, just to get that impact resistance. So instead, they just use our Durra panel as that sort of one-stop product.
Okay, thanks. I will give you a bit of a spell, Steve. Thanks everyone for the questions coming in too. They're rippers. So Ray, just that there's a question from Michelle around the Krone Premos machine. Does look amazing. How does it handle at 2.5 tonne per hectare plus stubbles, and does it leave the paddock suitable for sowing? Any observational comment there, Ray?
Yeah, so the harvest technique is to get the grain or the header to go through as close as possible to the grain, which probably most people are familiar with. Some of the stubbles in the high rainfall zone are pretty heavy, so some of the operators are growing feed wheats that are yielding 10 to 12 tonnes to the hectare. So that's the sort of biomass that we're talking about. It would be then windrowed, ready for pickup by the crone, and the height at which it's cut would be around about beer can height, Graeme, so that it's nice and ready to go in with cropping gear for the next winter, sowing of the next winter's crop.
Yep, that's right. No, thank you. That's terrific. And I guess that makes a point. Rachel's made a good point. It's great to hear about these exciting projects, and just curious about how much stubble's left on the ground when the stubble's removed. Is there a risk of too much, taking too much and putting the soil condition at risk? And I guess that's part of what we're sort of saying at the beginning, that, you know, retaining stubble is really critical. Where this really comes into play is for those either seasons or places where we're dealing with pretty high loads of stubble. So that sort of 10-tonne crop there, you know, got 5 and 10 tonne of stubble or more there. That's in addition to trying to leave the 2 or 3 tonnes which we're trying to leave for stubble retention. So yeah, no, that's fantastic. So this is a technical one. How many heat units to the tonne of pellets? That's just you don't have to answer that right at the moment, in fact, because at the end we will offer your contact details, so some of these can be taken up online.
It's a good question, Graeme, and one that I've got a little bit of an indirect answer for, if I could, and I will get to understand what a tonne of pellets produces in terms of megajoules of energy by comparison. What I can say is that the business case allowed for a 180 kilowatt system operating at peak capacity, and that the volume of pellets is estimated to be around about 200 tonnes per annum.
Yeah, great. Yeah, fantastic. Yeah, thanks, Lachlan. Campbell, welcome too. Doing great things up in the northeast there. And it's a pretty powerful, that photo you show, Ray, of the smoke, of showing a paddock of stubble that's put, you know, basically that 150 tonnes of stubble in the atmosphere of smoke, when that same roughly equivalent amount of energy could heat a whole hospital for a year. You know, that's a pretty, and employ a few people in the process. So it's a pretty, and displace fossil fuels. So it's there's a few wins in there. So I get why you're excited. Gabriel Hakim, welcome. Have the calculations been made on reduction in emissions from reduction in stubble burning versus the burning in the bioenergy system? I guess I just sort of probably comment that would be part of it, I guess, in any discussions with working out the calculation here, because there's a few different things about how well it's burned in a paddock versus the high quality burning in a proper facility. So good question. I think we've got a lot more work to do, though, Gabriel, on, and both for the straw panel and these productive uses, about the carbon story of them will all vary depending on the actual site and how much energy is used to sort of harvest and transport, and how things are treated there. So there's plenty of room for us to answer that.
And Graeme, we know that the business case also reflects a reduction in emissions with the use of pellets compared to LPG. I just haven't got the number in front of me at the moment, that's all. Yeah.
And good question from Fiona Robertson, soil guru, and she can help us with this. Great to see productive uses of extra straw. Just interested in the question of how much can we sustainably remove from a paddock, and that trade-off with benefits to the soil. So again, I think that's part of the questions that we can understand more about. And part of this too is not so much about taking perhaps this volume of straw from the same paddock each and every year. It's probably going to be something that's well more suited to particular, it's rotated around a particular farm that's in the business of grain production, because farmers are pretty keen on retaining organic matter and also trying to build up carbon soils themselves with soil. So that's all part of the mix. And as we know with straw too, you're also taking, there's a nutrient cost of anything that you take out of the paddock, whether it's grain or straw. So all of that's part of the cost and making sure people are paid enough to at least replace that. So some more questions from Joe. Welcome, Joe. Question for Ray. Great initiative for farmers in the local community. Approximately how many tonnes of stubble might there be available in the Western Districts of Victoria? So you had a good, you could probably just repeat just the few farmers you're working with. There's some pretty significant figures there just with that small handful of farmers.
Yeah, I can give a response to both of those. So 50,000 tonnes across 14,000 hectares. So that's at an average yield of 3.5 tonnes. And we know the guys are getting well above that in seasons like we've just had.
And that's how many farmers, Ray? That's only
9
farmers. So there's a few more than that across the whole Western District, isn't there?
Yeah, so I saw some figures recently from Sustainability Victoria, who'd mapped biomass materials, and the estimate for this part of the world was 1.9 million tonnes annually. So that's some significant energy potential right there.
Yep. Yeah, no, that's significant. Yeah, that's terrific. So there's plenty of room. So Colin's popped in and said, Sora did some work to show that at least 1 tonne a hectare is needed to sustain soil carbon and minimise wind and soil erosion. So that was the beer can height. But I think with a lot of those resources we pointed to earlier, between the 1 and the 2.5 tonne of residual was needed. One question that pops up a bit is about, well, if there is some tonnage of straw that's removed from the paddock, it actually does have some embodied fertility or nutrient in it. And so the question is, what sort of prices might farmers expect or need to be paid to make that worth their while? So it's in front. Any observations from Steve or Ray around sort of costs? Or feel free to pop in to Colin, because I know Colin's probably across some of this.
I'll comment for a start, if you like, Graeme, to the study that we did about 3 years ago when we looked at low-cost straw bale production, trying to maximise, the capital investment and all of those other inputs to produce a tonne of straw through large squares. And I'm pretty sure that the nutrient was factored into that equation at the time. I just haven't got the number there, sorry.
No, that's okay. That's all good. So thanks for everyone with those questions. I mean, some really good stuff here. It's a hot topic. I really hope we can see a lot more of this sort of thing happening in future years. And while we don't have all the answers now, it's all part of when we know humans are smart when we put our brains to it. And so there's been a couple of great examples here today of the smart work that you're doing. I was just going to finish with a question to you both about, in terms of the next 5 or 10 years, if we wanted to see more productive use of stubbles and straw like this, what sort of things do you think are needed to try and actually get more productive use of straw? So I'll start with you, Steve, if you've got any thoughts on what sort of things might help us grow this amount of activity.
Yeah, well, definitely. I think, we can play a part in that. I mean, at the moment, we sort of, average around purchasing of, 3,000 to 5,000 tonnes of straw a year, or stubble, I should say. So, I think, as mentioned before by in the chat box, if people or governments are using initiatives to use locally sourced materials, building designers, making better choices in building materials and things like that, then, we're essentially locking this carbon away into a useful product in lieu of timber and plasterboard products. So I think that's just got such a positive impact on the environment. And, at the end of the building's life cycle, it can go back into the ground at the end of its useful life. These days people are, building life cycle or the age of a building it's not long at all, really, when you look at houses or bathroom renovations and kitchens and how long they stay around before they're pulled down and redone and material throw away. You think about all the resources poured into that, it's enormous. But, you know, I think it's starting to change, and we're definitely noticing a big nudge in people using better materials in the building industry. And I think if people keep pushing that, we can, you know, hopefully, you know, purchase more and more stubble and, you know, produce more and more square metres of panel that can go across, you know, over the world.
Yeah, thanks, Steve. Just on that, so you're based at the factory is at Bendigo. So how many people does it employ, that sort of plant?
We generally have about 30 people employed, because on the other side of that panel, we also roll form our own steel sections as well, which, as you know, Graeme, it's our full ceiling and wall systems that we do. So there is a large, a good impact on that as our business grows with, you know, using local transport, local suppliers, and, you know, obviously the local workforce in that, you know, in rural Victoria.
Yeah, okay, no, that's great. Great little insight into the potential of the future. So there could be one in lots of regional towns in 20 years' time. Here's hoping.
I think the big movement that we've seen as well, Graeme, is we're actually in the midst of, you know, technology transfer into another country too. So they're looking at the same situation where they have enormous stubble that they actually, this company actually do their own, grow their own wheat, and they want to do the whole thing. So sell their crops and also use the stubble to manufacture Durapanel. So that's really exciting for us, and that should be happening at some stage later this year.
Very good. Thanks, Steve. Well, much appreciated you joining us today and sharing your story. And Ray, you've been doing some great work up there at the Pyrenees Shire, and congrats. And, you know, if we're trying to encourage more of this sort of work and more productive uses of straw in the next 5-10 years, what sort of things, from your point of view, think will help?
I think there's got to be good collaboration across government at all three tiers, so local, state and federal, to consider wheat straw, but also biomass in all its forms, as essentially a technology that can provide baseload power that's available 24/7, irrespective of what weather conditions might be. And there's an opportunity waiting. And I'd also see that there's an opportunity for the university sector here as well. And I guess the interest that we have locally at council is it's about supporting the resilience of rural and regional communities by providing new job opportunities, and also the prospect that whereas currently we're importing equipment from Europe, I'm sure we've got people smart enough locally that could manufacture this stuff in this country that could also add to jobs and growth locally.
Yeah, and as you mentioned, Ray, some of that closed, you know, the closed systems, you've got employment and income generation all happening at that local scale, because this is really something, you know, there's a limit to how far you want to bring straw and biomass from. So it's got this nice, neat little tie into rebuilding and supporting rural economies. So, so congratulations on the work you've been doing. Now, for both Steve and Ray, what's the best way of getting hold of you if people want to contact you afterwards? Ray, what's the best way to get in touch with you?
Yeah, they can send me an email at ray.davies, DAVIES, at pyrenees.vic.gov.au.
Right, thank you. And Steve?
Yes, just Steve at ortech.com.au. I can put that in the chat box if you like.
Yep, great, thank you. And I'm sure Heather will follow that up too. So I want to thank you, Heather, too, for organising the webinar today. Done a great job. Thank you very much. And thanks to everyone who's joined us. And Heather, are you still there?
I am still here. I did drop out a little bit during those questions with a little internet issue, but I am back. So I I did get to enjoy most of the answers to those questions, and thank you everyone for the great discussion and the great questions. It's been quite an interesting topic and one that there was certainly a lot of interest in. So we did have about 60 people online today joining in live, and I'm sure even more will join and listen to the recording as well. So everyone who has registered today will get an email from me shortly with the recording and also some details for future webinars. So I would also like to thank Ray, Steve and Graeme for their presentations today, and certainly a lot to think about there. And if anyone's got any further questions that they didn't get answered today or think of, just let me know and I can pass those on to Ray, Steve or Graeme. So thank you, everyone, and we enjoy your afternoon, and I'll make sure I get the recording out to you as soon as possible so you can have another listen if you need to.
Thanks.
Great work. Thanks everyone.
Thank you.
See ya.
Thanks, everyone. Bye.